Okay, this is question 8, calculus question. A golfer strikes his golf ball from an elevated position. The flight path of the ball is given by the following formula, where h, the height, is equal to 25 plus 0.4x minus 0.002x squared, where h is the height in meters above ground level and x is the horizontal distance in meters from where the golf ball is struck. Okay, so if you actually look at this, there you have your quadratic arc here, hence why we have an x squared and x and a number in it. Okay, so part A says to find the height above ground level from which the golf ball is struck. So we have to think about this. Has the ball travelled any distance at all? No, it hasn't. When it's up here, it hasn't travelled distance at all, which is what we're looking for. Okay, so in this case we say x, which is the horizontal distance, is now going to be 0. So if we want to find the height of the ball, we sub 0 in wherever we see x. Okay, and you're just left with 25 meters. So the golfer is striking the ball from 25 meters. Okay, so part B says, at the instant the golf ball is struck, a bird passes in the flight path of the ball. The position of the bird is 45 meters above ground level and a horizontal distance of 75 meters from the point where the ball is struck. Assuming the time lapse is negligible, state whether the golf ball passes over, strikes, or passes under the bird and justify your answer. Okay, well if the bird is a horizontal distance of 75 meters, we have to assume that that's how far the golf ball is going to travel. Okay, so let's say 75 meters is here, the bird is somewhere up here, we have to find where the ball is after 75 meters. So we're going to sub 75 into the formula, right? So h is going to equal 25 plus 0.4 multiplied by 75 minus 0.002 multiplied by 75 squared. So that's going to equal 25 plus 30 minus 11.25. And your final answer then is 43 meters, 0.75. Okay, so 43.75 is less than 45. Therefore, ball passes under the bird. Okay. So part C says find the horizontal distance that the golf ball has travelled when it reaches its maximum height above ground level. Now there's a bit of a clue kind of thrown in here, guys. If you see them put in the word maximum or minimum, more often than not what they want you to do is differentiate first and let it equal 0. Okay, so that's what I'm going to do. So to find the maximum height, okay, I differentiate. So it's going to be, we'll say, instead of say h, we're going to say dh dx, where it's going to be 0.4 and it's going to be minus 0.004 x. Okay, and once that's differentiated, we're going to let that equal 0. So 0.4 minus 0.004 x is equal to 0. Minus 0.004 x is equal to 0.4. Sorry, minus 0.4 because it goes over the equals. Change the sign. 0.004 x is equal to 0.4. And x is going to equal 0.4 divided by 0.004. And your final answer is x is equal to 100 meters. Okay? So that's how far the ball has travelled. So 100 meters is about where it's at its maximum height there. Okay, so the next question says, what is the maximum height that the golf ball reaches above the elevated position from which it is struck? Well, we know that it reaches its maximum height after it has travelled 100 meters. Okay, so we're going to sub 100 in for x. So h is equal to 25 plus 0.4 multiplied by 100 minus 0.002 times 100 squared. Okay, which is going to equal 25 plus 40 minus 20, which is equal to 20 meters. So that means the ball will have gone up 20 meters by the time it's reached 100 meters. Okay, so find the horizontal distance as the golf ball has travelled when it strikes the ground. Well, we know that when the ball hits the ground, it's going to have a height of 0. So I can let h equal 0. So I let the whole quadratic formula equal 0. Alright, and if you multiply everything by 1,000 here, it'll give you numbers that are easier to work with. You get 2x squared minus 400x minus 25,000. Okay, so yeah, they're larger numbers, but at least you're not messing around with any kind of decimal places. Alright, and this can be simplified. Divide by 2, you get x squared minus 200x minus 12,500. Okay, 12,500, which is equal to 0. Alright, so now you're ready to start your solving of the quadratic. So a is equal to 1, b is equal to minus 200, and c is equal to minus 12,500. And you're going to sub it into your minus b formula, plus or minus the square root of b squared minus 4ac all over 2a. So all you have to do is sub in your values. Okay, so that's going to equal minus b minus minus 200 is going to be 200 plus or minus the square root of b squared, which is going to be minus 200 to be squared minus 4 times a, which is 1, times c, which is 12, minus 12,500. Okay, and all of that is all going to be over 2 times a, or 2 times 1, which is just going to be 2. Alright, so I'm going to just pull this all together. So you get 200 plus or minus the square root of 90,000. Okay, and that's going to be divided by 2. The square root of 90,000 is equal to 300, so you're going to have 200 plus or minus 300 divided by 2. So now we're going to split it up. We'll go with 200 plus 300 divided by 2, which is going to equal 250, because 500 divided by 2 is 250. Or we could go 200 minus 300 divided by 2, which is going to equal minus 50. Okay? Now, you're probably wondering why we have a positive number and a negative number. Okay? Now, you got to remember that the quadratic is just a representation of where the ball has gone. Alright, so if we go back to the question here, it represents the ball going from here to here. But if I finish this quadratic off, the ball can actually go back here, in theory, alright? But obviously the ball is not going to go there. So this is just the reason why I have a negative answer here. If I tracked this back here, this would be 50 meters here. This is 50 meters between here and here, okay? But the ball has actually travelled from here to here 250, which is why I can eliminate this. This is not possibly an answer. The ball didn't travel backwards, alright? It must have travelled forwards. 250 meters is your answer. And that is the calculus question, question 8, paper 1.